This is the second video for section 4.3, probability. In this video, we will compute theoretical probabilities and compute empirical probabilities. We will begin with example 4. Example 4. Find the following theoretical probabilities when flipping a coin and then rolling a die. Part A. Probability of heads and an even number. So here we will want to look for the outcomes where you flip heads and then roll an even number. So this table comes straight from the text. This table shows the 2 outcomes that could happen when you flip a coin, heads and tails, and the 6 outcomes that could happen when you roll a die, 1 through 6. And then inside the table, these represent like the outcome of flipping a heads and rolling a 1. Flipping a heads and rolling a 2, so on and so forth. So I'm going to circle in red here. I will circle the outcomes that we're looking for, right? Flipping a heads and rolling an even number. So those outcomes are like this one right here, heads and rolling a 2. Or you could flip heads and roll a 4. Or you could flip heads and roll a 6. Right? So there are those 1, 2, 3 outcomes where you flip heads and roll an even number. So 3 outcomes with heads and even out of 12 outcomes total in the sample space. Let me go back to my pen, which reduces to 3 out of 12 or 1/4 probability. Okay, we'll do the same thing for part B. Find the probability of tails and anything besides a 2. I'm going to use green this time. I will do green boxes. So again, we'll use this table to find the outcomes where I flip tails and roll anything besides a 2. So those outcomes could be tails and a 1, or tails and a 3, or tails and a 4, or tails and a 5, or tails and a 6. So again, in those green boxes, those 5 outcomes are where I flip tails and roll anything besides a 2. So 5 outcomes with tails and anything besides a 2 out of 12 outcomes in the sample space gives a probability of 5/12. Example 5. On your way to work, you pass through 2 stoplights. A stoplight could be red, green, or yellow when you pass through. Find the following theoretical probabilities. Before we find these probabilities, we will draw a tree to show us all of the outcomes here. So let's have the beginning here. Here's your start. So the first stoplight that you pass through could be red, green, or yellow. So from your start, here is the first stoplight. Could be red, green, or yellow. The second stoplight that you pass through could also be red, green, or yellow. Red, green, or yellow. And red, green, or yellow. Okay. Again, you could have made a vertical or a horizontal tree. I choose to make mine like this. And this shows all of the outcomes that are possible when you pass through 2 stoplights on your way to work. So find the probability that all stoplights you pass through are green. So again, we want to look for all the outcomes that satisfy that, divided by the total number of outcomes in the sample space. So looking for all the outcomes, all the outcomes where all stoplights are green. Let me use a green pen here. So the first stoplight you pass through, you would want to be green. And the second stoplight you pass through, you would want to be green as well, right? So I circled that here in green. There is 1 outcome where all stoplights you pass through are green out of 9 outcomes total in the sample space. So that gives a probability of 1/9. Okay, part B. Find the probability that all stoplights are green, red, or yellow. For part B, that's all that can happen, right? Your stoplight can only be green, red, or yellow. There's no other color it can be. So all 9 of these outcomes actually have both stoplights as green, red, or yellow. That's all that could happen. So there are 9 outcomes with all stoplights green, red, or yellow. And again, 9 outcomes in the sample space. Here we go. So that gives a probability of 9 out of 9, which simplifies to 1. You'll note that an event with probability 1 will happen all the time, right? All the time when you pass through those stoplights, they are red, green, or yellow. That's it. Okay, part C. Find the probability of an equal number of green and red stoplights, at least one of each. Okay, let me go back to our tree here. So at least one of each. Since we have 2 stoplights, this means that I'm looking for 1 red, 1 green stoplight. Again, the first step is to interpret what this means, right? An equal number of red and green, at least one of each. And since there's 2 stoplights, that means exactly 1 red, exactly 1 green. So I will use red pen here to circle those outcomes. So the first stoplight you pass through could be red, then the second stoplight you pass through would have to be green, right? To have exactly 1 of each. Alternatively, the first stoplight you pass through could be green, and then the second stoplight you pass through would be red, also to have 1 of each, right? So there are 2 outcomes with an equal number of red and green stoplights, and 9 outcomes in your sample space. Gives a total probability of 2 9ths. The sum of all probabilities from the outcomes in a sample space is 1. That represents 100% of the results possible. So for example, when you flip a coin, heads or tails are the only 2 things that could happen. So the probability of heads or tails is 1. This result is stated in this blue box here, the sum of probabilities of all outcomes. Again, if a sample space is separated into outcomes A, B, C, so on and so forth, then the sum of all those probabilities is equal to 1. Empirical probability. Probability using data collected or observed is called empirical probability. Empirical probability is not always exactly the same as theoretical. That is what you expect to happen. Theoretical probability may not always be what actually happens. What actually happens is your empirical probability. Example 6. In the United States in April 2023, an online survey found that 44 out of 100 U.S. adults use TikTok. If a U.S. adult was selected at random, what is the probability that the adult uses TikTok? So here, I will just want to put in the numerator the number of adults that use TikTok, and that's 44, divided by, 44 out of 100 adults, right? So divided by 100. And so that gives a probability of 44 out of 100. Which reduces to 11 out of 25. Example 7. A 2022 study found the following video game preferences of adolescents, 5th grade through 8th grade. Using the data presented in the bar graph, find the following probabilities. What is the probability that a randomly selected adolescent from this study is male? So here we want to find the probability of male. This means in the numerator, I want to count the number of males from this study. And then in the denominator, I want the total number of people involved in this study. Let me write this down. So in the numerator, I will want to count the number of males in this study, right? The number of outcomes that satisfy what I'm looking for. divided by the total number of adolescents included in this study. Okay, so I will use green circles here. So I'll make it green circles. So the number of males in this study, males are represented by these blue bars. So there's 13 males here and 14 here, 63 here, and 11 here. So the number of males in this study is 13 plus 14 plus 63 plus 11. Out of then your total number of adolescents, well, the total is the gray bar, right? So I'll do this in black. So 34, 22, 113, and another 22. So 34, 22, 113, and another 22. So then that simplifies to 101 out of 191. Part B. What is the probability that a randomly selected adolescent from this study enjoys playing Battle Royale? So again, let's keep that 191 from before. That's the total number of adolescents included in this study. So no reason for me to find that again, right? So now I want to look for the folks who enjoy playing Battle Royale. So let me use red this time. I'll do red boxes. So here's Battle Royale, right? And there are 113 people total that enjoy playing Battle Royale. So that will be my numerator here, right? 113 out of 191. Part C. What is the probability that a randomly selected adolescent from this study is female and enjoys playing strategy and puzzle games? I'm going to abbreviate that SP. Okay, so let's go look for who is female and enjoys playing strategy and puzzle games. I'll use blue. So here's strategy and puzzle, right? And then female, there's 8 of them. So this probability would be 8 out of 191. This concludes example 6, and this concludes video 2.